Hello guys, myself Dr. Swapnil Shinde and welcome back to lecture series on linear algebra. Already I have explained plenty of the video based on the linear algebra in our channel. So if you are interested to see this video guys, you can check in my playlist. Okay, so in my previous lecture I explained to you all here eigenvalue and eigenvector, how they work and their properties. So in our today's video guys, I'm gonna explain to you all one of the example based on our previous property and definitions. Okay, so let's find out eigenvalue for a given matrix A, which is I have written here 14 minus 10 5 minus 1. Okay, so we want the eigenvalue. So first of all, verify whether it is lower diagonal, upper diagonal, or only the diagonal matrix. Then easily we define the diagonal entries are eigenvalue. But it seems like that we do not have such entries here. So what do? We apply standard method for finding the eigenvalues. Okay, I'll explain to you all with the two methods. One of the standard characteristic equation and another one is a quadratic equation, polynomial equation. Okay, that we use the characteristic equation in a polynomial form. Okay, first of all I'll explain to you all this one is our given matrix. Okay, first of all I will explain to you all a characteristic equation. Okay, using characteristic equation. Okay, what is the characteristic equation for finding the eigenvalue that we learned in our previous lecture? Yes, exactly, a minus lambda I. Okay, a minus lambda I. Okay, and their determinant which is equal to 0. This is the characteristic equation guys. I explained in my previous lecture how it works. Okay, so I proved it in my previous lecture. If you want to see how this is coming, go and check in my last lecture. Okay, so using this characteristic equation we want the eigenvalue for our matrix. Okay, so matrix A it is here. As matrix A is a 2 by 2 matrix. Okay, what is the order of matrix A? Is a 2 by 2. Obviously identity matrix whichever is coming, it will be also for order 2 by 2. Okay, 1 0 0 1. This one is the identity matrix of a 2 by 2. Okay, so let me write a minus lambda I now. A is here a determinant of 14 minus 10 5 minus 1. Okay, minus lambda times I. Okay, I identity matrix 1 0 0 1. Okay, which is equal to 0. This one is our required characteristic equation. Okay, and how we subtract the matrix? We subtract corresponding elements. Okay, so lambda into 1 is lambda, lambda into 1 is lambda, and these are the two 0. Okay, so we write the matrix 14 minus lambda. Okay, so first element of our matrix is a 14 minus lambda minus 10 minus 0 times lambda means only minus 10. 5 minus lambda times 0 is a 5 only, minus 1 minus lambda times 1. Okay, so minus 1 minus lambda. Okay, which is equal to 0. See carefully guys, it is very easy. Okay, nothing is difficult, just need to subtract. Okay, for corresponding element 14 minus lambda into 1, 14 minus lambda, or you can multiply lambda to this matrix first. You will get the diagonal entry lambda lambda. So 14 minus lambda minus 1 minus lambda, this one is diagonal entry, and minus 10 minus 0 minus 10 5 minus 0 5. Okay, so what we do later on, we have to find out the determinant of this matrix. Okay, so how we can find the determinant? We multiply cross elements and subtract from each other. Okay, yes, 14 minus lambda, 14 minus lambda multiplied by minus 1 minus lambda, minus 1 minus lambda. Okay, and which subtract from 5 into 10 minus 50. Okay, minus 50, which is equal to 0. This is the way I have written here. Okay, so later on go for solving further, you will get the simplified form. Okay, so 14 minus lambda minus 1 minus lambda, so you have to multiply these two bracket plus 50 which is equal to 0. Okay, so 14 minus lambda minus 1 minus lambda minus minus plus 50, take it to the other side, you will get the minus 50. Okay, yes, so if you want you can make it more simpler, take minus out from here, 1 plus lambda will be there, and that minus to the other side it gives us plus 50. So it is completely up to you. Okay, what to do? Yes, what do we do? Multiply this into this, this into this, minus this into this into this. Okay, this way you have to multiply. Okay, 14 into minus 1, 14 into minus 1 minus 14. Okay, 14 into minus lambda minus 14 lambda. Okay, 14 into minus lambda minus 14 lambda, minus lambda into minus 1. Okay, this into this. So you have to multiply element. Okay, so 14 into minus 1 minus 14 minus lambda minus 14. Okay, minus 14 into minus lambda. So you write this one, minus lambda into minus 1. So it is a plus lambda, and a minus lambda into minus lambda. Okay, minus minus plus lambda square. Okay, yes. So, and which is equal to minus 50. So try reduce the similar term, lambda square, 14 minus 14 lambda plus lambda minus 13 lambda minus 14, and take that minus 50 to the other side. It will gives us the plus 50, which is equal to 0. Okay, so you reduce further. Okay, so we write lambda square minus 13 lambda square minus 13 lambda 15 minus 14, we write 36 plus 36, which is equal to 0. This one is the characteristic equation for our given matrix A. Okay, this one is the given characteristic this one is the characteristic equation. By using A minus lambda I we solved. Okay, yes. So there we have one more method that you can apply for finding the characteristic equation. Okay, that means we write this method as a lambda square, okay, minus trace of A into lambda plus determinant of A, which is equal to 0. Okay, so lambda square keep as it is minus trace of A, 14 plus minus 1, that means it is 13 lambda plus determinant of A. Once you find the determinant, you will get the 36, which is equal to 0. So you can see that this equation and this equation both are equal. Okay, so instead of finding this entire process, you can remember this characteristic equation and find out the directly values. Okay, so later on you have to find out the root for this equation. Okay, it is very easy. I hope you all have understood these two alternative methods. Okay, not the difficult. This is the standard characteristic equation which having trace of A and determinant. Okay, lambda square as it is, trace of A means addition of a diagonal 13 minus 13, lambda is as it is, and determinant of A, which is a 36. Okay, this one is our standard characteristic equation. So you can go by this, you will get this one, and you go by this way, you will get similar. Okay, yes. Now our next task is to find out the roots of our characteristic equation. Okay, roots of the characteristic equation. So that means we want the two element, their multiplication is 36. Their multiplication is a plus 36 and their addition is a minus 13. So what are the possible element? 9 4 is 36. So we write a minus 9 multiplied by minus 4. Minus minus plus, 9 4 is 36. And if we add for this minus 9 plus minus 4. So you will get the minus 13. Okay. So I got the two factors, minus 4 and minus 9. Okay. That means we write lambda minus 9 and lambda minus 4, which is equal to 0. These are the factors for this equation. Okay, these are the factors for this equation. So we write lambda which is equal to 9 and lambda which is equal to 4. These are the two eigenvalues. Now see that eigenvalues are 9 and 4. We got the eigenvalue. That is the only solution for our given matrix. Okay, so this is the entire process, guys, for finding the eigenvalue of a matrix A. It is very easy. That way you can define. Okay, so I explain alternate method here also. So this lambda is 9 and 4 are the two eigenvalues. Okay, so I want you all to solve some of the example for your homework. Here I have some of the example for your homework, guys. Use this matrix, find out their eigenvalue and tell me in my comment section. Second one, third one and fourth one. I'm having these three matrix. You're supposed to find out their eigenvalues. Okay, and let me know in my comment section eigenvalues for these three matrix. Okay, it is very easy, guys. Find out the standard process, try apply some standard results and let me know in my comment section what are the eigenvalues for our given matrix. Okay, so that's it here for the eigenvalues, guys. For the eigenvector, I'll explain to you all from my next lecture onward. I hope you all have understood everything here. That's it for my today's lecture. For eigenvector, will be going for our next lecture. So thank you everyone. Thank you for my today's lecture.